We will move on to the next presenter. We are right back on schedule. Stephan Robinson from the National Physical Laboratory, Teddington in England. The floor is yours, Stephan.
Hello, everybody. Can you all hear me?
Yes.
Okay, so I'm going to talk about the standards work in JOMOPANS, which was done on the work package 3. I just thought I'd say something initially about why we care about standards at all. And the reason is we want to be able to talk to each other in a language we all understand, so there's no misunderstandings and no ambiguity, but also so that we can compare the measurements and modeling done by different researchers so that they're made in a comparable way and an equivalent way. So that we're comparing apples and apples and not apples and oranges. And here are two examples of where standards went wrong, if you like, one very old, one more recent. The Vasa warship was a Swedish warship. Its maiden voyage in 1628 was a disaster. It sank. And when it was excavated by archaeologists in 1961, they found that once it was lopsided, which contributed to the sinking. And they found the tools used by the ship makers. The rulers were calibrated using different standards. One set of rulers was calibrated using an Amsterdam foot and one using a Swedish foot, which were not the same. And this contributed to the asymmetry in the boat, which contributed to the sinking. More recently, 2003, the Laufenburg Bridge, which straddles Germany and Switzerland, when it was built over the river, they found that it didn't meet in the middle. There was a 54 centimeter difference in height, and that was because Germany and Switzerland used different datums for sea level. Germany using the North Sea, and the Swiss follow the French and use the Mediterranean Sea, and these are different. So this led to a very expensive and unfortunate correction that had to be made, and the whole bridge had to be lifted on one side. So we obviously wanted to avoid that kind of issue within JOMOPANS. So we had a particular work package, a specific work package on standardization. And we found, of course, that there were no existing international standards for monitoring ocean ambient sound. So we had to come up with some of our own, building on some of the work of earlier projects, for example, the EU Bias project and a number of other guidance, good practice guides and so forth. And we came up with 4 different protocols or standards for the project, which I'll describe in a minute. And these will now form the output of, which will feed into international standardization within ISO. So first of all, there was a standard on terminology. So this defined the language we're going to use, if you like, the key terms and metrics. We could build upon some existing standards. So there was some standards from the ISO on the basic terms for acoustics, if you like, and we built upon those. We also wanted to have strong coherence with other projects that were going on simultaneously to ours. Obviously, we could build a little bit on the EU Bias project I mentioned, but the main project we liaised with was the ADION project, which is a US project, mainly because they also had a specific objective and deliverable on standardization. And so as far as we could, we made it our terminology standard coherent with theirs, using some of their terms as the basis of ours. They have slightly different objectives to JOMOPANS, so it couldn't be exactly the same, but nevertheless, we made it as coherent as we could. We also have a standard for equipment and deployment. So this defined what the basic specification of the equipment had to be in order for it to be used in the project. As you've already heard from Jens, there were different kinds of measuring equipment used. We didn't standardize on one type. So some types of equipment were fixed cabled hydrophones where the cable goes back to shore, but also some shorter term autonomous recorders were used, mainly sound traps and wildlife acoustics recorders. And we defined again how those must be used and provided guidance for the deployment methodologies, including guidance for things like trying to avoid flow noise, although within the very high tidal environment you have in the North Sea, this is a very difficult thing to do completely, and it wasn't really possible to avoid the influence of flow noise completely in the results. We also covered calibration in the same document, and here we could build upon a recently published IEC standard where some of the partners in JOMOPANS were involved in the project to publish that standard and draft that standard, and also the work of a previous EU project called UNACLO, which developed some methodologies for measuring autonomous recorders and calibrating them. And again, two of the partners in JOMOPANS were involved in that EU project, so we could build on that expertise. One thing we discovered during the project was that we needed to be sure that there was an equivalence between the calibrations carried out between all the partners, mainly so that we could determine whether any of the differences we observed between the modeling and the measurement results were caused by potential calibration offsets or biases in the calibration. So we hosted a workshop at MPL on calibration attended by the partners, and then we organized a comparison of calibrations between all the partners where MPL calibrated an instrument used by each of the partners, and we compared the results. And from this, we were able to define a degree of equivalence, a mutual equivalence between the calibrations with an uncertainty of 1.5 decibels, which put a tolerance on the amount, if you like, the degree of disagreement one might expect due purely to the calibrations between the modeling and the measurement. And we found that actually was something that wasn't necessarily planned at the start of the exercise, but this need developed during the project, and it was a very useful exercise in the end during the project to do the calibration workshop. We also have a standard on data analysis. This was mentioned briefly by Jens in the previous presentation. Here, we wanted to define how the key acoustic metrics were calculated from the measured data. And there's quite a detailed description of that, but we also wanted to provide some benchmarking because each partner would use their own software code to implement the metrics and the algorithms and the calculations. So we had to test again that these were all mutually equivalent. So we produced some synthesized noise data with known statistics because it's been synthesized by us separately using computer code. And we then circulated this blind to all of the partners, and all of them analyzed this using the procedure defined in the JOMOPANS data analysis procedure, and we compared the results, and the results were in agreement within a fraction of a decibel. So that demonstrated that that each of the partner could analyze the data in a mutually equivalent way, and this was not a significant source of discrepancy between the results. And finally, there's the modeling standard, which again, Chris de Jong in his presentation mentioned something about that. And he was the working group 5 people, Jens and his colleagues were very instrumental in the equipment and data analysis procedure, working with us at MPL. And here TNO really took the lead on this one, producing this modeling standard. It covers choice of propagation models and the influence and how to choose the correct environmental parameters, and the source models and AIS data and their use in producing the noise maps. This obviously focuses on the way it's done for JOMOPANS, but there are many generic lessons, if you like, that come out of this, which are highlighted in the procedure. And it also describes the benchmarking exercise that Chris mentioned earlier, where a number of different models were benchmarked with, again, performance was tested against benchmark scenarios, and the results were compared, again, to see that there was a mutual equivalence between the different models. So finally, then, I'd just like to say something about the future and the legacy of JOMOPANS and the standardization work in JOMOPANS. We have these 4 documents, which are available or will be available very soon in their final form on the website. But these are now going to form outputs that will feed into future ISO standards. I said at the start that there's no international standard at the moment, and that's true, but a new working group started this year. There is working group 5 as part of ISO TC43 SC3 on monitoring ocean ambient sound. The new work item proposal has been circulated now, and this will be discussed at the October meeting of that ISO standards group. And these standards within JOMOPANS will provide input to the work of that ISO committee, and the JOMOPANS partners will themselves be active within that committee. The chair of the entire committee is one of the JOMOPANS partners, and the leader of some of the work items in this working group and the leader of the entire working group is associated with JOMOPANS. So consequently, JOMOPANS will have quite a significant input and influence in the future development of ISO standards, which will be to the benefit of all doing this kind of monitoring in the future. And so that's the end of my presentation. I'm happy to answer any questions.
Er zijn geen vragen op dit moment.
Okay. Okay, thank you very much, Stephan. Thank you very much for this interesting presentation. I heard just from Barry that we have no questions from the chat. So I may have just a small question before we go into the coffee break. Maybe not an easy one, because you are the person for standardization, but at the same time, we look, for example, for one of the output parameters at a variable baseline in terms of the excess levels are referenced based on the fluctuations in wind. So we will have shielded areas, we will have quiet periods in the year, and that immediately puts kind of a shift to that standardization. How do you see that?
I don't think you can. First of all, perhaps we can take the discussion of the wind into the panel discussion, because I think I'd like to have Chris de Jong's input into that. But on the standardization aspect in itself, here we're only talking about standardizing the basic methodologies that can be written into a procedure. You can't. I don't think we're at the stage where we can prescribe standards for what you're talking about here. That's the next step, which we're not really at yet. But remember, before we started this project, there were no real standards that could be used. So we've come a long way in this project in defining the standards that we've got. So I think it's better to take that question into the discussion later. Is that okay?
It was a little bit of a teaser, of course, because I think it's very important work to do the standardization, and I think there was a really nice job done. But at the same time, we should be aware that not everybody understands what is standardized and what that means. So I think taking it to the discussion after the next series of presentations, I think it's a good thing to come back to the wind issue, and that's that shift that we put into the data with that output parameter. That having said, Stephan, thank you very much. We take a 15-minute break for some coffee.